to do differentiation here with exponential and logarithmic functions. This is an exponential function. And the nice thing to remember, and which is kind of interesting and unusual, is that the derivative of e to the x is equal to e to the x. It's very unusual. So the derivative of this function is equal to itself. So let's take a look at this, and let's see if we can solve it. So I want to find y prime. Well, I have a product right here. So product is going to be uv plus uv, with the prime going backwards there. So my u prime is 1 times e squared plus, well, the derivative of e squared times x. But remember, e is a constant. It's approximately 2.718. So e squared is going to be a constant, and the derivative of any constant is 0. So it's going to be 0 times x minus, well, the derivative of e to the x is itself, e to the x. So the derivative here is equal to e squared, that goes away, minus e to the x. The thing that is likely to throw you off in this problem is the derivative of e squared. Just remember, e is a number. It's a constant. Even though it's an irrational constant, so is pi, but everybody recognizes that as a constant. And if I square it, it's just going to be a constant still. So don't get thrown off by that being a constant. Let's do another one of these with base e. So I want to find y prime, and I know that the derivative of e to the x is e to the x, so this is going to employ the chain rule. I'm going to have e to the x squared as the derivative of this, but that's the outside function. I also have the inside function right there, which is the derivative of that would be 2x. So I have e to the x squared times 2x, and that's my answer. We can just write it 2x e to the x squared. This is, again, the derivative of e is itself, but since I have a chain rule and a function as the exponent, I have to use the chain rule.